Hello everyone, welcome back to the channel. This is Moy Gowda B, bearing the lesson 1V21CS 101. Today we are going to learn about renewable energy and power plants. So today in renewable energy and power plants, we are going to learn about windmills and wind energy. So what is wind energy? Wind energy harnesses the power of wind to generate electricity. So, windmills, also known as wind turbines, are the devices that capture this energy and convert it into a usable form. The windmill is a structure that converts wind power into rotational energy using vanes called sails or blades. By tradition, specifically to mill grain, but in some parts of English speaking words, the term is also extended to encompass wind pumps, wind turbines, and other applications. Now, take a look at the history of wind power. Ancient origins. Windmills were first built in ancient Persia for grinding grain. Medieval Europe. Windmills were widely adopted in Europe for milling grains and pumping water. In the modern era, the development of wind turbines for electricity generation began in the 20th century. So, how a windmill works. First, wind strikes blades. When the wind blows past the blades of a windmill, it creates a lift and drag forces, which results in the rotation of the blades. Second, the rotation. When the wind blows, the blades rotate, spinning a shaft connected to a generator. Third, electricity production. When the blade rotates, the generator converts the mechanical energy into electrical energy, which is used in the daily uses. So now let's take a look at the types of windmill designs. The horizontal axis windmill. The most common design, blades rotate around a horizontal axis. Horizontal axis wind turbines have the main rotor shaft and electrical generator at the top of the tower and must be pointed into the wind. Since a tower produces turbulence behind it, the turbulent uh, turbine is usually positioned upwind of its supporting tower. The vertical axis windmill. Blades rotate around a vertical axis more efficient in low wind speeds. The generator is placed at the bottom of the tower, whereas the blades are covered around the shaft. The vertical axis wind turbine working principle is that the rotor in the turbine revolve around a vertical shaft by using vertically oriented blades. So they generate electricity by using wind power. The offshore wind farms. Wind turbines located in the ocean, often with larger capacities. Offshore wind farms generate electricity from wind blowing across the sea. They are considered more efficient than onshore wind farms, thanks to the higher speed of wind, greater consistency, and lack of physical interference that the land or human-made objects can present. So now let's take a look at the advantages of wind energy. First, renewable resource. Wind is a naturally replenishing source of energy. Second, clean energy. Wind energy produces no greenhouse gas emissions during operation. Third, economic benefits. Creates jobs in manufacturing, construction, and operation. Fourth, energy security. Reduces reliance on fossil fuels and improves energy independence. So, what are the challenges in wind energy deployment? Intermittency. Wind is not always available, requiring energy storage solution. Environmental concerns. Impact on wildlife, noise pollution, and visual aesthetics. Land use. Large area of land are required for wind farms. Cost. Initial investment costs can be high, though prices are decreasing. Let's take a look at the wind energy's role in renewable energy. Diversification. Wind energy complements other renewable sources like solar and hydro. Grid integration. Wind power helps balance the electricity grid and reduce reliance on fossil fuels. Sustainable future. Wind energy is a key component in transitioning to a cleaner and more sustainable energy system. So, what are the environmental impact of wind farms? Wildlife impact. Wind turbines can pose risk to birds and bats, requiring careful setting and mitigation measures. Noise pollution. Wind turbines can generate noise, particularly at close distances, requiring noise reduction techniques. Visual impact. Wind farms can have visual impact on landscapes, requiring aesthetic considerations in siting. Now, let's take the future of wind power technology. Offshore wind. Growth in offshore wind farms with larger turbines and advanced technologies. Floating wind. Developing floating wind turbines for deeper waters, expanding the potential of offshore wind. Distributed wind. Increased use of small-scale wind turbines for residential and commercial applications. So now, the conclusion and the key takeaways of windmills and wind energy. Wind energy offers a sustainable and clean alternative to fossil fuels. It plays a crucial role in the transition to a renewable energy future. Challenges exist, but continued technology advancements and policy supports can enhance the role of wind power in meeting global energy needs. So that's it about today's video on windmills and wind energy. Please do like. Thank you.